Hey everyone, and welcome back. Today we're taking a deep dive into the world of large language models, or LLMs for short.
Always pushing the boundaries, aren't we?
You know it, but this time we're focusing on something called multi-token prediction. I'm really curious about this.
Oh, hey, our listener wants to join in. What's up?
In this paper, that head refer to attention head.
That's a great observation. It's easy to get those terms confused.
Yeah, when we talk about heads in multi-token prediction, it's not the same thing as attention heads.
Exactly. The paper is talking about output heads, which are separate from those attention heads in the transformer architecture.
So like the attention heads are part of the main model, but the output heads are something different.
Yes, the output heads are used to predict future tokens. Each one has its own softmax output.
So they work in parallel to predict multiple future tokens at the same time, unlike the attention heads which process the input.
Precisely. It's a crucial distinction. These output heads are what enable the multi-token prediction.
Okay, that clears that up for me. Thanks for pointing that out.
Of course. Now, where were we? Yes, the training process.
So before we get too deep into these output heads, could you remind me how the typical training process for LLMs work?
Oh, go for it.
What's the relationship between multiple heads?
That's a great question. It's important to understand how these heads interact.
Right, they're not just randomly predicting tokens. Let's clarify that.
So while each output head focuses on a different future token, they actually all share the same underlying model, that main trunk.
Exactly. It's like a team of specialists using the same source material, or in this case, the processed input.
And they're all trained together, so they implicitly learn from each other, making predictions more coordinated.
Precisely, they're not working in total isolation. It's more of a collaborative process, and they share information.
So even though the heads have different specialties, they still collaborate? That makes sense.
It's like each head is a different perspective, but all based on the same information.
Okay, I think I understand the relationship between these multiple heads now. That's super helpful.
Glad we could clear that up. Now let's get back to the training.
Yeah, so how does the typical training process for these models work?
Well, think of it like planning a road trip. If you only focus on the next mile, you might miss a crucial turn.
Okay, so multi-token prediction isn't just about the next step.
Right. It's like looking ahead at the whole route, making the model more strategic.
Okay, so instead of just the next step, it's considering the entire journey. That makes sense.
But how does the model actually predict multiple tokens at the same time? That's what we're talking about.
That's where the output heads we just talked about come in.
Picture the model as having a main body, the trunk, that processes input text.
And then you've got these multiple output heads, each focusing on a different future token in the sequence.
Exactly. If we're predicting 4 tokens, we'd have 4 output heads working in parallel.
Each head analyzes the same input, but specializes in predicting a different position down the line.
It's a way to capture those long-range dependencies in the text we talked about earlier.
Whoa, that's cool. It's like a team of experts, each with a unique perspective on the future.
And this architecture allows them to work together implicitly to understand the text more cohesively.
So even though they have different specialties, they're still collaborating?
It's amazing how we can leverage parallel processing for such a complex task like this.
It really is. Now, I'm really interested in this self-speculative decoding you mentioned.
That's a great point. Self-speculative decoding significantly speeds up text generation using the multiple heads.
Self-speculative decoding. That sounds intriguing. I'm always a fan of speed improvements.
It's like the model is a chess grandmaster considering multiple moves simultaneously.
Instead of one token at a time, it explores various potential sequences in parallel.
Then it evaluates these options and picks the most promising one. It's all about brainstorming possibilities in advance.
That's incredibly efficient. But doesn't that require a lot more computational power?
It does require more upfront, but the speed gains during decoding offset that.
It's like investing a little extra effort to get things done much quicker overall.
Exactly. And multiple output heads allows for this self-speculative decoding, making LLMs faster.
Okay, so what other benefits did the researchers find in the paper?
Well, aside from speed, they found that multi-token prediction leads to more sample-efficient models.
So they learn quicker and need less data to achieve good performance?
Yes. Anything that helps reduce that data requirement is a win for these massive LLMs.
Absolutely. And the researchers also look at byte-level tokenization with multi-token prediction.
That's a good point. Let's quickly remind ourselves what byte-level tokenization means.
It's about breaking down the text into the smallest bits, the individual bytes.
Think of it as the building blocks of digital information.
Right, we've talked about different types of tokenization before. So what happened when they used it?
Even with byte-level tokenization, the multi-token model achieved near token-level model performance.
Wow, so it's faster, more efficient, and works well with a simpler way of breaking down text.
Exactly. The model was also a better reasoner. Specifically, it was better at generating code.
Okay, now that's impressive. Faster, more efficient, and smarter. Tell me more about this improved reasoning.
They put these models through challenging programming tests, and multi-token models aced them consistently.
So predicting multiple tokens at once forced them to think through the logic more thoroughly.
It's not just about stringing code snits together, it's about understanding the underlying logic.
Interesting. So what do they call that kind of token in the paper?
This is where the concept of choice point tokens comes in, a key idea highlighted in the paper.
Choice point tokens, those sound important. What are they exactly?
Imagine navigating a maze. There are points where the path splits, and you have to make a crucial decision.
So a choice point is a critical decision point in the sequence. Got it.
Precisely. Multi-token prediction implicitly trains the model to pay more attention to these choice points.
So it's like learning to make key decisions correctly because they heavily influence what comes next.
It's like the model's becoming more strategic, focusing its energy on decisions that really matter.
That makes a lot of sense, especially in code generation where one wrong character can mess things up.
You nailed it. And this ability to focus on crucial decisions gives us some insights into how multi-token prediction improves training.
Okay, I'm all ears. How does it improve the training process?
Well, it all ties back to reducing the difference between training and real-world use.
Ah, I see. So because each prediction is based on the previous one, a small mistake early on can snowball.
Exactly. Multi-token prediction forces the model to look ahead at multiple future tokens.
So it's like giving the model a sneak peek at the consequences of its decisions.
Yes. It encourages the model to make predictions that are more consistent with real-world text generation.
So it's like giving the model a taste of real-world decision-making during its training.
It is. It's all about making the model a more independent and robust learner.
This has been incredibly insightful. It's clear that there are some really impressive benefits to multi-token prediction.
We have just dipped our toes in, but it's fascinating, right?
Definitely. And it's exciting to see how this new approach to training LLMs is opening up so many possibilities.
What's next? How about we take a moment to summarize the key takeaways?
Great idea. Let's solidify those main points before we venture further into this world.
Sounds good. Ready to jump back into multi-token prediction?
Absolutely. My brain's still buzzing about choice points and self-speculative decoding. It's amazing how researchers are pushing the limits.
It really is. And what's even more exciting is that we're still in the early stages of this research.
That's what makes it so captivating. It's like we're on the cusp of a whole new era in AI.
Right. One big challenge is figuring out the optimal number of tokens to predict and how that might change with the task.
So no one-size-fits-all solution, huh?
Right. The ideal number likely depends on the task, the data, and many other things.
Wouldn't it be amazing if we could develop algorithms that automatically figure that out?
That would be incredible. It would make multi-token prediction even more powerful and flexible.
Totally agree. And think about this. What if we could apply multi-token prediction beyond language and code?
Could we use it to predict sequences in music or image generation?
Whoa, that's a really cool thought. Imagine an AI that could predict notes or a series of frames.
Exactly. And remember how multi-token prediction can speed up inference by 3 times? Imagine pushing that further.
Faster inference means more responsive systems, which is a big deal for real-time applications.
For sure. But beyond speed, I'm also excited about the potential for multi-token prediction to make these models more explainable.
Explainable. Okay, you've piqued my interest. Tell me more about that.
Well, right now, LLMs are often considered black boxes. We don't always understand the logic behind their decisions.
I know what you mean. It's frustrating when you can't see the thought process behind the output.
Precisely. This lack of transparency is a problem, especially in fields like healthcare or finance.
Transparency is critical in situations like that. So how can multi-token predictions help with explainability?
Because the model looks ahead at multiple future steps, we might be able to retrace its reasoning more effectively.
So we'd see the steps it took to get there, not just the final answer.
It's all about creating more transparent and interpretable AI systems.
You know, it's interesting how the paper highlighted code generation as an area where multi-token prediction shines.
Code has a rigid structure and logic. It's about instructions a computer can understand and execute.
So precision is everything in code. Every symbol, every character matters.
You got it. And that's where multi-token prediction comes in.
By predicting multiple tokens at once, the model thinks about the program's logic more effectively.
It has to anticipate how each decision affects what comes next.
It's like the model is learning to think like a programmer.
Love that analogy. And the results speak for themselves, outperforming in programming benchmarks.
Fascinating. What about natural language, though? Do we see similar benefits there?
It's trickier with natural language. Language is inherently fluid and ambiguous.
Right, language is all about meaning and nuance, which could be very subjective.
While the paper showed some improvements in summarization, the gains weren't as dramatic as in code generation.
We still have a lot to learn about how to effectively apply multi-token prediction to human language.
Absolutely. It's a reminder that this research is a continuous journey.
This deep dive has been a serious mental workout. Multi-token prediction is opening up many possibilities for LLMs.
It really is, but the key takeaway is that it's a powerful new tool in our AI toolbox.
Totally agree. And it's pushing us to rethink how we train and interact with these models, for sure.
And remember how multi-token prediction might help us understand the reasoning behind the model's choices.
You mean like lifting the curtain on the black box?
Right. That's a prime area for future research, and it's critical that we understand how these models work.
Makes sense. We want to make sure they align with our values and that we can use them responsibly.
Exactly. Now, remember we talked about fine-tuning LLMs using multi-token prediction?
Fine-tuning, isn't that different from training a model from the ground up?
It is. Fine-tuning is taking a pre-trained model and further training it on a more focused data set.
So instead of starting from zero, we can leverage those powerful pre-trained models.
Yes, and refine them for specific applications using multi-token prediction, like a software upgrade.
It sounds like we're on the brink of a new era in AI.
I think so too. But this also raises important questions about how we evaluate these increasingly sophisticated LLMs.
Couldn't agree more. Like any powerful technology, it has potential for both good and bad.
Well said. This has been an incredible exploration of multi-token prediction.
Me too. It feels like we're witnessing the birth of a new era in AI.
The pleasure's all mine. It's always inspiring to discuss these topics with someone as enthusiastic as you are.
Well, that's what the deep dive's all about. Who knows? Maybe someone listening will be inspired to make the next big AI breakthrough.
That would be amazing. The future of LLMs is bright, and multi-token prediction is just the beginning.
It feels like it. And to think, subtle tweaks can have a massive impact. Amazing.
It really underscores that sometimes the biggest leaps forward come from rethinking the fundamentals.
Totally. So before we wrap up, let's do a quick recap of the key takeaways about multi-token prediction.
Love it. Let's crystallize those key insights.
Okay, so the core idea is that instead of predicting just the next word, we're predicting several at once, right?
Bingo. That shift from a local to a more global view seems to be driving all the impressive benefits we've discussed.
Like that faster inference, thanks to that clever self-speculative decoding, that was a mind blower.
Right. It's like a super efficient brainstorming session happening inside the AI.
And it's not just speed either. Remember the improved sample efficiency. They can learn a lot more from less data.
Absolutely. And even more impressive is how well multi-token prediction works with byte-level tokenization.
Which is a much simpler way of breaking down text, right?
Exactly. It's like the model can extract meaning from these tiny little pieces of information.
It really does. And of course, there's the improved reasoning abilities, especially with code generation.
It seems like that act of predicting multiple tokens at once forces the model to think more strategically.
And all of this links back to those choice point tokens, right? Those crucial decision points in the sequence.
You got it. Multi-token prediction seems to naturally guide the model to focus on those critical moments.
Which in turn makes the model better at handling the uncertainties of real-world text generation, right?
Right on. It's all about bridging the gap between training and the messy reality of real-world applications.
This whole deep dive has been a real journey. Multi-token prediction is opening up a whole new world of possibilities for LLMs.
It really is. We're just at the beginning, but it's clear that this has the potential to be a game changer.
Before we finish, could you touch on that idea of fine-tuning existing LLMs with multi-token prediction?
Absolutely. Imagine taking one of those massive pre-trained LLMs and giving it a specialized boost with multi-token.
So we can leverage those existing capabilities and fine-tune them for very specific applications.
Yes, we're essentially upgrading these models, enhancing their performance without having to rebuild the system.
That's incredibly exciting. It feels like we're on the verge of a new era in AI.
Agreed. But we can't forget about the ethical considerations. As we unlock these capabilities, we need to be careful.
Absolutely. With great power comes great responsibility, right?
Well said. These are critical questions that researchers and developers need to grapple with.
This deep dive has given us so much to think about. Multi-token prediction is truly a revolution in the making for LLMs.
It really is. It's a testament to human ingenuity and our drive to push the boundaries. It's a thrilling time to be in this field.
It sure is. Well, that wraps up our deep dive into the world of multi-token prediction.
We encourage you to keep exploring this topic, read the research paper, and keep those questions coming.
Thanks for joining us on this deep dive. Until next time, keep learning, keep exploring, and keep that curiosity alive.
This was a fantastic exploration. And with that, we conclude this episode of the show.